Let's go over Lewis symbols in this little pencast. And so Lewis symbols represents only electrons in the valence shell. Okay, that's it. You don't write the core electrons, and if you forgot what core electrons are, go to the pencast before, but really core are inside and valence are the outermost electrons. So for example, if you look at sodium, sodium will have only one electron in the valence shell. And why only one electron in the valence shell? And that is because it is ending in S1. So whether it is in the third shell or fourth shell, it doesn't matter. It will always end in S1, so which means it will only have one electron. So we write only the valence electron for it. Now you can write the electron as a cross. You can also write it as a dot, okay, like this. So one important thing that I would like to tell you, and I usually mention this in my lecture in class, but when you have something of an element, you're writing a symbol, remember that you are writing the atomic mass over here, the atomic number over here. This is the mass number on the top. And then for any element, you will write the charge on that element. So sodium plus or whatever 2 plus you will write here. And at this corner, you are going to write the number of atoms in bonding. Okay, so if you had something like CaCl2, so if you had calcium chloride, this spot is reserved for showing how many chlorines you have in there. So what I'm trying to say is that each spot is a special thing, okay? And these spots over here, up and down and left and right, these are left for showing the electrons, okay, that we have. So when you write your Lewis symbol, I want you to be careful and write it either up, down, or left or right, okay? So which means that you can write sodium like this, you can write sodium like this, you can write sodium like this, as you wish, okay? Just don't write them in the corners. So this way actually is not quite correct, although this could seem like it's on the right hand side, but be careful when you're writing it, okay? It just helps with the representation. Okay, so going on with Lewis symbols, for chlorine, it's going to be 7 electrons. Why? Because in the valence shell, you have 7 electrons. How do you also know it has 7 electrons? And that is because it is in group number 7. Group number 7 has 7 valence electrons. Group number 4, like carbon, okay, the first element in group number 4 will have only 4 electrons. So this is like one of the easiest things to remember or to figure out is just look at the periodic table. Whatever group number you have is also the number of valence electrons you have, okay? So it's the easiest thing to remember. So this is how you would write Lewis symbols for just elements. If you had ions, so for example, if you had sodium ion means that it lost 1 electron. So if it lost 1 electron, now sodium doesn't have that 1 electron in there. So now you will just write Na plus, okay? And that is it. So that is the Lewis structure for sodium ion because it doesn't have any electrons. So for chloride ion gains 1 electron. So for the chloride ion, you would write Cl, and then let me write dot here just for the heck of it. And then you have these 4, 5, 6, 7, 8 electrons. Because chlorine already had 7 electrons, now it got 1 more. For the anions, what you have to do is you have to put square brackets around them and put the charge outside, okay, so that you know that it's actually an anion. You don't have to do that for the cations, all right? So that's how you do it. For oxygen ion, which is the oxide, it gains 2 electrons. So again, you have oxygen here, 1, 2, 3, 4, 5, 6, 7, 8. Put the brackets around, and now this is 2 minus, okay? So that's how you would write the Lewis symbol for oxide ion. So this is how it's done. Now writing Lewis structure for ionic compounds. These ones are written just a little bit differently than covalent compounds would be, so please pay attention and do this for ionic. How do you know something is an ionic compound? First of all, you know you have an ionic compound when you have a metal and a non-metal, okay? That's how you know. If you have carbon dioxide, okay, then both of these are non-metals. So if they're both non-metals, that is going to be a covalent compound or a covalent bonding. So this one here is going to be ionic bonding because you have a metal and a non-metal. So when you're writing Lewis structures, the first thing you do is identify if you have a metal or a non-metal. So for example, if I give you aluminum oxide, then this is going to be ionic. If I give you methane, CH4, this is going to be covalent. Why? Because you have two non-metals in there. Okay, so now let's write the Lewis structure for ionic compounds. So I will say, for example, write the Lewis structure for, let's say, aluminum oxide, okay, by itself. Or I can say between aluminum and oxygen. All right, so which means that you have to figure out what kind of a compound to form. So now you have to go back to your chapter 2 and then remember from there that aluminum is 3 plus and oxygen is 2 minus, and then you do your crisscross from there and then you get Al2O3. Now once you know how many atoms you have of each, now you can go ahead and write the Lewis structure because you know you have 2 of aluminum, which is 3 plus, and you have 3 oxygens. So you write the oxygen first, which is 8 electrons. You put the square brackets and you have the 2 minus. That has not changed. What you will do then is you will put 3 in front of the oxygen outside the bracket, and that shows that you have the Lewis structure for aluminum oxide. Okay, let's write another one. Let's do between calcium and chlorine. So calcium is 2 plus because it's in group number 2, so it gives 2 electrons, so it's 2 plus, and chlorine is -1 because it's group number 7, it needs only 1 more electron. So then you do the crisscross and you have CaCl2. So you need 2 of chlorine in order to balance out the charge. Remember that the final molecule should be neutral. Okay, we do polyatomic ions later. Right now everything is neutral. So to write the Lewis structure for calcium chloride, you will have calcium as 2 plus. Calcium doesn't have any electrons left now. It gave both of them to chlorine. And chlorine, you will write, it becomes chloride now. It's not chlorine anymore. If you say chlorine, then that would seem it is Cl2. Okay, so when you say chloride, you automatically know you're talking about a chlorine that has accepted an electron. So here this is chloride accepted an electron, and because you have 2 of those, you will write this like this. All right, so this is the Lewis structure. This is it. This is the answer. So you have to watch out because covalent compounds are very different from ionic structures. Okay, so in the next pencast, I'll show you how to do covalent structures.